Welcome back guys to my channel. In today's video guys, I'm gonna show how to ensure the stability of the building of our house here, right? So first of all, you have to understand that this is our concrete building, right? And to make it reinforced, I'm gonna use steel bars inside my concrete, right? Because we know that the concrete can resist the compression forces, but the tension force it can't resist the tension force. So I need to impose the steel bars inside the concrete, right, to make it both it make the concrete resist both tension and also compression, right? So this the quick mindset of the concrete reinforcement. Okay, and as you can see, i'm gonna reinforce my concrete according to the load that I apply on my concrete building. First of all, we have the wind loads in two different direction, right? We also have the seismic loads, different eccentricity, right? Seismic load is just the earthquake, and also we have the safe weight, of the building. It's also called the dead load, right? So it means that it's the part of the building. So the building gonna carry that force forever. You know what I'm saying, right? So it's the safe weight of the building, right? It's about the material. It's about many stuff, right? I list everything before. You can just go and watch my video. And also we also have the movable loads, means the life load, the load that I can move, right? They can change according to the time. They can change, right? So that I'm saying, right? So I'm gonna just apply the life load, dead loads, seismic load, and the wind loads, right? So my building should be able, in every extreme condition, to resist those forces, right? No matter what. So as an engineer, you have to know how much money you're gonna make. First of all, you have to know how much money you're gonna spend on the on the reinforce of your house, of your building, right? But the most important thing that you have to consider is the stability of your house, of your building, right? In under any circumstances, your building should be stable and also should be comfortable, right? So let's start, guys. So this is the robust structure analysis. So I import all of the forces before. You can check my previous video. So this this is the forces that I put everything here, and I also do the load combination in SLS, serviceability limit states, and also ultimate limit states. All right, so you can just watch the previous video. But in today's video, I'm gonna show you how to reinforce your concrete. This is the first part. So we have to go on design, and under design here, we must see that we have the steel member design. We have the steel member design option here. We have the steel connection design. We have main option here, right? But the first thing that you have to do, you have to distinguish, because you have many member on our building here, right? We have the vertical one, we have the horizontal one, we also have the so have different member, right? Have a different member, right? So but for me, in my opinion, right, we only have like the main parts. We only have the vertical one here, the columns, right? And horizontal one here is horizontal one here, and also the vertical one inside here. I mean the horizontal, this horizontal or beam, they're beams, right? So the column support the beam, right? And also the beam support the floor, right? Easy. So the floor is the one that has some gap inside. You can see the gap. So I just replaced the flow by their forces, right? I calculated it before. Do you remember? Yeah, you can just go and watch the previous videos. All right, thank you. So here I'm gonna distinguish what is beam and what is column. So I'm gonna go on required force reinforcement of beam and column option here, and I'm gonna go on code parameter. I'm gonna go on code parameter. I'm gonna click there, and as you can see here, we only have two options here. We have reinforce columns and reinforce beam, right? So I need to indicate to the computer which one is concrete and which one is column and which one is beam. So I'm gonna just start from you can see the line member, they're empty, right? So I'm gonna click on this line member here, and then I'm gonna click on one of my column here. right? And I'm gonna right click again, and I'm gonna select all of the column by going on select similar, and because they have the same member type, even the same material, I think, okay, the same member type, right? So if you just click on select member, they have the same member type, you can see all of my columns, they've been selected. So I'm going to click again on the line member. You can see from 136 to 64 to 99. These are the member, right? So this the number of the member. So these members, all of these member represent the columns, right? So I'm going to click, I'm going to go here on reinforced concrete. You can see there's indicator here, means that this everything here, the columns, right? So I need to reinforce this member according to the column compression, like behavior, right? Behavior of the column, right? So I'm gonna click on apply. Okay, so I'm gonna repeat the same process for the beam. As you can see here, we have the column already, so I'm gonna do the same for the beam. So I'm gonna just click on one beam. Let's say let me click on this beam here, and I'm gonna right click on it, and then I'm gonna select. So let me click on one first. I can just zoom it out, zoom in, sorry. And then I'm gonna right click, and then I'm gonna go on select similar, and they have the same member type. And as you can see, all of the beam, these are the beams, right? I told you that this beam, they've been supported by the columns, right? So all of the member in the blue color, the beams, right? So I'm gonna click again here. You can see all of these lines in the member here are 37, 63, 100, 126, 252. All of these member represents our beam. So I'm gonna go again here. I'm gonna click on the beam here, and then I'm gonna click apply. Right, apply. So I distinguish beam and columns. So it's really important before everything, right? So before any other design, you have to distinguish which one is column and which one is beam. Okay, so I'm gonna close this. But as you can see, you have more option here. We have detailed lists. We also have the standard lists. I don't want to use this because my design is not that complex. It's just very simple, right? And we also have the view with large icon. I don't want to use all of this, but if you're designing a huge building, right, you might need to use all of this because it's gonna be hard for you to pick the member, right? So I'm gonna close it. If again I go on design, if I go on design again here and I click, let's just see, I click on, because I have the slab here, right? I have a slab here, but I don't have walls, right? So let me just show you again. If I click on required reinforcement of slab and walls, right? If I click on it and then I take the code parameter, you can see that. So it's gonna be, I'm gonna show in the next in the next video, sorry, how to select the floor, because you also have the floor. We need to consider the floor, but we don't have the wall yet because the wall is not main part of, is not main part, means that the part that's maintain the stability of the house. The wall can be removed, and the structure of the skeleton of the house gonna remain constant, right? Means that the column and the beam are really important, and also the flow, right? The flow. So I'm gonna show in the next video how to do it. So, but before I finish with this video, I'm gonna show something again. So if I close here, and then if I go again on, if I go on design, and then I go on requires reinforcement of beam and column here, right? If I click on it, right, so you have to wait a little bit. It's kind of slow, guys. Anyway, guys, if you find this video both entertaining, educative, please subscribe to the channel for more contents, guys. Like the video, share the video, guys. Thank you so much. All right. So, and here, right, and this is the table, right? So here you can see, okay, let me just let me make this one bigger. All right. All right, so we can see, right, you can see this is the list of the member, the first concrete. So we have the column and also you have the beam, the section, right? So you have column and the beam, and here we can see reinforce beam, reinforce column, and for the B, the reinforce beam, right? This is just a table, and you can see the type of the beam that I'm gonna use. I'm using 6x6, but I'm gonna show you in detail in the next video. So this is just a quick summary of what I'm gonna show in the next video, and I'm gonna also use this chord combination. I did this already, but for the calculation I didn't do it, so I need to also maintain the stability of my house according to this chord combination, ULS and SLS, especially ultimate limit state, and also SLS is stability limit state. So LSS is for the comfort, house comfort, like building comfort, and for the ULS is when like we have to know under any extreme condition the building should be able to carry all of the loads without collapsing, right? So guys, if you find this video both entertaining and educative, don't forget to like the video, share the video, and also for more content, subscribe to the channel, guys. Share the video, guys. All right, see you in the next one.